Greetings everyone and welcome to this year's Year 12 Chemistry. I'm your chemistry teacher Mrs. Kumar and together we are going to embark on a new journey for this year's Year 12 Chemistry. So let's begin with our Strand 1.1 which is Uncertainities in Measurements. So what is uncertainty? Well, when we are uncertain or unsure of anything, there is always a dilemma. That is what happens in our real life. However, in chemistry, uncertainty has to do with measurements. Here, one particular object can have various measurements depending on the type of device or instrument it is used to measure. Such as, if we are looking at this paper clip, you can see that an estimation has been made on the length of the paper clip which appears to be 2.3 centimeter. It can be 2.3 or it can be 2.4 centimeter. However, when the same paper clip is measured on a different ruler, you can see that the numbers are now more accurate. So the reading is now showing a 2.3 centimeter. We cannot say that there is any error in the measurements, but we do say that these measurements are carrying some sort of uncertainty in them. So we are going to learn how we are going to use uncertainty in measurement, as well as we are going to be learning a few terms which are associated with uncertainties. So the first word that we need to learn is exact numbers. Exact numbers are those numbers which are known exactly. Like for example, when we have to count the number of apples or the number of eggs, we can count these items without having a doubt. So these numbers are said to be exact. That means they do not carry any uncertainty in them. However, an inexact number is going to have some uncertainty to them. Like for example, a measurement can read as 1.3 meters, but on a different device, it can read as a 1.31 or a 1.29. Now, all these measurements are having some sort of uncertainty to them because of the different instruments they are used. Accuracy and precision are two important factors to consider when taking data measurements. Both accuracy and precision reflect on how close a measurement is to an actual value. But accuracy means how close a measured value is to a true value, while precision is the closeness of two or more measurements to one another. Let's say, for instance, there is a measurement of a 50 gram standard sample. So 50 grams standard sample is a true value. And if the same experiment or the same object is weighed on a different instrument, we will get values of, let's say for example, we are getting values of 47.5, 47.6, 47.5 and 47.7. So 47.5, 47.6 and 47.7. They are far from the 50 grams. That is a true value. Therefore, we say that this result is having a low accuracy. But the three values that is obtained like 47.5, 47.6 and 47.7, they are close to each other. Therefore, their precision is high. Let's look at a scenario here. So we have a dartboard, and as we know that the dartboard contains the bullseye. This bullseye is going to be our standard or the true value. So notice how the darts are spread across the board. Now in this case, the four darts are away from the bullseye, which means that they are having low accuracy. At the same time, the four darts are far away from each other. So we say they have low precision as well. In the second example, you can see that the four darts are still away from the bull's eye. However, they are close to one another. So if they are far away from the true value, which is a bullseye, we say the accuracy is low. But because the four of them are close to each other, we say the precision is high. In the third example, you can see again that the four darts are away from the true value. so they will be low accuracy, and they are away from each other as well, so it will have a low precision. And then finally, if we look at this picture here, it shows that all the four darts are on the bull's eye. So we say that they have a high accuracy, and also they are very close to each other. So they are having a high precision. So students, I hope you have understood the difference between accuracy and precision. Now we are moving on to the different types of errors that are usually encountered in our calculations and experimental procedures. The first type of error that is encountered in any experiment is systematic error. Systematic errors are also known as repetitive error. Now, these errors are consistent, which means that the reading that is going to be shown in one device is going to be same when the reading is going to be repeated, when the experiment is going to be repeated on the same device. And this error is arising due to the faulty machines or incorrect experimental apparatus. So let's say, for example, there is a scale pen, and this scale pen, without having anything put on top, it still shows a reading of 0.02 grams. So this simply means that this is an instrumental error. Whenever the same balance is going to be used for the same sample, the result is going to be consistent. We are going to get the same mass. The other error is known as a random error. The random errors are human errors. These errors are not repetitive. They are different depending on the person who is repeating it. So usually it is to do with the experimenter's inability to do the experiment. So it basically means that the person doesn't know the technique of doing the experiment, and as a result is going to result in a random error, such as parallax errors. So parallax error is an error that results from a measurement when an incorrect eye reading level is used. So if you can see here, the red readings that are obtained in this measurement, they are incorrect, because the correct way of taking the measurement in this case is through the eye level. The eye level and the lower meniscus should be in line with each other. So the green one is showing a correct reading, while the red readings are incorrect, and that is an example of a random error. For any measurements, there must be two things that should accompany it. Number one, it should have a numerical value, which is a magnitude, and it should have an uncertainty. And this uncertainty is denoted by the plus and the minus sign. So let's say, for example, there is a measurement which reads as 1.25. So this 1.25 milliliter basically means that it is not a correct value. It may have some sort of uncertainty to that. So if this value reads as 1.25 plus or minus 0.05, it basically means that you add 0.05 to the value and you may end up getting 1.30. If you subtract 0.05 from the 1.25, you will get 1.20. So that basically means that the reading is falling in the range of 1.2 to a 1.3 milliliters. So 1.2 to a 1.3 milliliter range is very far. It's a very far range. Okay. And usually we use a very narrow range whenever we are writing uncertainty. And also uncertainty should always contain a one significant figure. So if the value that is measured contains a one decimal place, then our uncertainty should also have a one decimal place, and it will be a 0.1. So let's say, for example, if there is a reading which reads as 10.1 milliliter. Now 10.1 has one decimal place. So the uncertainty should have a one decimal place, and this will be 10.1 plus or minus 0.1 milliliter. If the value in the measurement has two decimal places, then the uncertainty will also have two decimal places, and that will be 0.01. So if we have a measurement of 10.11, 10.11 has two decimal places. So the uncertainty would read as 10.11 plus or minus 0.01 milliliters. So basically, students, I hope you have understood the concept of how to write the uncertainty. It is very important that you use the digit 1 in your uncertainty so that we have a narrow range of uncertainties. Okay, and also the measurement should have the same number of decimal places as your uncertainty. Next, let's see how we are going to take measurements and we are going to write them using uncertainty. So if we have a measuring cylinder and it takes a reading as such. So how are we going to take readings? So the first thing I'm going to do is to share a trick with you as to how we take readings of any measuring device. So step number 1, always ensure that you are able to mark out the lower meniscus. So the lower meniscus is a lower curve right at the bottom where the reading is going to be shown. Okay. Now we are going to look at the difference between the two digits and then divide it by the number of divisions. So it means, let's say for example, we take any two differences. So we take a difference between 2 and 3. The difference between 2 and 3 is 1. And between 2 and 3, there are 10 divisions. So 1 divided by 10 will give you 0.1. So it basically means that each division has a 0.1 value. So we will have 1 at the bottom and this is going to be 0.1. So 1 plus 0.1 will be 1.1. So we will have 1.1, 1.2, 1.3, 1.4, 1.5, etc. So when we come to this particular reading, it will, so when we are looking at this particular reading, you can see this is 2, this is 0.1, so that's 2.1, 2.2, 2.3, 2.4, 2.5, 2.6. So you can see this is 2.6. Now this lower meniscus is actually above 2.6. It's kind of the middle of 2.6 and 2.7. So the middle of that we take it as 0.05. So 0.05 added to 2.6 we get 2.65. Now this is our estimation. So here we can say that the reading is 2.65 milliliters. So now we put the uncertainty. Since our measurement has 2 decimal places, our uncertainty will have 2 decimal places as well. And that uncertainty will be 0.01 ml. Let's look at another example as to how we are going to take a measurement in this particular glassware. So let's say we have a lower meniscus shown here. Okay, so this is where, so this is our lower meniscus. So we are going to apply that trick that we have learned just a while ago. We look at the difference between the two numbers. So between 40 and 30, the difference is 10. Okay, so we are going to have 10 divided by 10 because we have 10 divisions between them. That's 1, that's 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 divisions, therefore 10 divided by 10 we have a value of 1. So what basically it means is that each of this line is having a value of 1. So if this is 30 and this is 1, so 30 plus 1 is 31. So now our value that is shown here will be what? So if this is 31, this will be 32, this will be 33. So we have 32 and 33, the value in between which is 32.5. Since this value is having 1 decimal place, our uncertainty is also having a 1 decimal place. So that is why we are writing the uncertainty as 0.1. So I hope students you have learned how you are going to take the reading of any device using uncertainty. It's time for the quiz now. Let's see how much you have learned in this particular topic. So looking at these three pictures, find out what is the level of accuracy and the level of precision in each one of them. You can pause the video, write your answers, and then you can cross-check with the one that is given. Okay, so let's see what our answers are. So in the first picture, you can see that the accuracy is high because all the balls are around the true value, which is the flag. And then the precision is also good because all the four balls are close to each other. In the second one, the accuracy is low because these balls are away from the true value. But their precision is high because they're all close to each other. And then when we look at the last one, you can see the accuracy and precision are both poor. They are both low because, first of all, the balls are away from the true value, so they have low accuracy. And the other one, they are also far away from each other, that is why they have poor precision. And the last question for today, what is the reading in this voltmeter? You can pause the video and then write your answer and then cross-check with the one that is going to be provided to you. Well, reading is 17.6 plus or minus 0.1 volts. So students, I hope you have enjoyed the lesson as much as I have enjoyed delivering it to you. Until then, take care. We will meet again in our next session of 1.2 where we are going to learn about dimensional analysis. Bye.